Alright, Trig Benchmark Part 1 review. So, these first ones we are using the point to figure out what the trigonometric function value would be. So, the idea here is, like number 2, if we had a coordinate plane and we went out 6 and up 17, to that point out here of 6, 17, when we drew that angle, what would be the sine of that angle? Okay, and remember the idea is we make that triangle with the x value being here, the y value being here, and this being your radius. If we were to make, a circle here. Okay, so the sine, remember, thinking back to SOHCAHTOA, this is what we're doing here, right? The sine is the opposite over the hypotenuse. So opposite would be the y value, hypotenuse would be the r value. So remember, sine, in this sense, is really the y over r. Okay? Cosine would be the adjacent and the hypotenuse. So cosine ends up being the x value over the radius. And finally, the tangent is opposite over adjacent. So the tangent becomes the y over the x. Okay? So, what we often have to do is find that radius. Okay? Because we're always given the x and the y because of the points. So to find the radius, we can just use the Pythagorean Theorem. Okay? Number 1 and 2, we're looking for sine, so we need that y value over r. So we need that radius. So, just do the Pythagorean Theorem here. Let me erase this out of the way. Okay, so we've got our y value, so I know it's going to be 2 square roots of 3 over something. So I go negative 2 squared plus 2 square roots of 3 squared equals r squared. So we get positive 4 plus 2 squared is 4 times square root of 3 squared is 3. 4 times 3 is 12. 4 plus 12 is 16. So we get 16 square root of it, which would be 4. So our radius equals 4. So I go 4, which I can reduce this, right, and just be square root of 3 over 2. And that's all we need to do here. Okay, number 2, same idea. I've got my y value. Now I just need my radius. So I go 6 squared plus 17 squared equals r squared. 6 squared is 36. 17 squared is, and I don't know this one off the top of my head, so I use my calculator. It's 289 equals r squared. Okay, add 36 and 289 to get 325. We take the square root of that, and we get a decimal, which is not what we want. So I get the square root of 325. So now I'm going to have to simplify this, right? So 325, I could probably divide it by 25. And if I do, I get 13. Well, I know the square root of 25 is 5. Don't know the square root of 13. So I get 17 over 5 roots of 13. Now, technically, I can't leave a radical on the bottom. Okay? So I'm going to have to times by the square root of 13 over the square root of 13. Okay, so we get 17 square roots of 13 over, those become 13, so I get 5 times 13, which gives us 65. And I don't think 17 divided by 65 gives us anything good. Nope, it doesn't. So that ends up being my answer. Kind of an ugly one, but still works. Okay, cosine now, looking at 3 and 4, cosine is all about the x value over the r value. So I know I have negative 14 over something. So negative 14 squared plus 14 squared equals r squared. So I get 196 on both of them. So 392 equals r squared. I don't think there's one for this, no. So again, we're going to have to simplify. So I could divide by 2 and I get 196, right? So let's go 392 divided by 4. I get 98. Okay, and I know the square root of 4 is 2, so I get 1, 2. Now 98, can we simplify that by another 4? We can't. We can by a 2, and I get 49. Well, I know the square root of 49, right, is 7, so 2 times 7 ends up being 14, and then square roots of 2, because I don't know the square root of 2. Okay, now again, we should remember I can cancel out the 14s, so negative 1 over the square root of 2, but I don't like to keep that square root of 2 on there, so I get negative square roots of 2 over 2, and that's my answer. Okay, so number 4, got my x, so I know 2 root 3 on the top, so 2 root 3 squared plus negative 2 squared equals r squared. I get 4 times 3 plus 4, 12 plus 4 gives us 16. Square root of 16 we know is 4, so I get 4, which I could simplify that to square root of 3 over 2 as well. Okay, so there's my answer. Now tangent we like the most, because tangent is just the x over the y over the x. So like number 6, y over x, I get 15 over 12, negative. Can I reduce that? Yeah, to 5/4, negative. Okay, 5 is a little bit harder, 7 over square root of 15, which we don't like that square root of 15, so being on the bottom, so I end up getting this instead. But tangent is definitely the easier out of all of those. Alright, so now we're going to use some law of sines and cosines, which is pretty much the whole rest of this, isn't it? Okay, so remember, we have law of sines. When we have a connection between a side and its opposite angle, we can set them equal to another side and another opposite angle. Now we write it like this for the formula, but we generally only use 2 of them, okay? And we can flip it, so we can do those on top and the sides on the bottom, okay? And we end up using just 2 of them. We should have 3 pieces of information and always looking for a 4th, whether that's an angle or a side, okay? So there's law of sines. Now, law of cosines is a little bit different, but this is what we have to use when we don't have a connection, right? And it's basically one side is equal to the other 2 sides squared added minus 2 times the other 2 sides times the cosine of the opposite angle. Okay. Again, though, we have 4 pieces of information. We'll know 3 of them, and we'll be finding a 4th. Okay. All right. So we want to find BC. BC would be little a. So we've got a connection here, law of sines. So I'm looking for a. So over the sine of 65 degrees equals 27. Oh, not 27, 5. Side, right? We keep the sides the same, over the sine of 27. So I times both sides by the sine of 65 degrees, and I'm going to get my answer. This then I'm going to type into my calculator and find my side length. Making sure I'm in degree mode, I get 9.98. It says round to the nearest tenth, so basically 10 if I round up. Okay, so 8, find AC. Same idea, this is a little b. Do I have a connection? We do for those 2, and now we do for these 2, so b over sine of 86 degrees equals 24 over sine of, that's 75, right? Or 73. Same process, times by sine of 86 on both sides, so b equals that multiplied by that. And we end up with 25.03, so basically 25 to round to the nearest tenth. Okay, so number 9, now we don't have a picture, but we could very easily just draw a picture, right? A, we call that 83. C, we call that 34. B, this would be little c, which is 22. And little a is what we're looking for. We've got a connection. So 22 over sine of 34 degrees equals a over sine of 83 degrees. Times both sides by the sine of 83. Okay, type it into our calculator, and we end up with side length 39.04, so basically 39. Okay, now we didn't necessarily need to draw the picture, so let's look at 10. And I see I have angle A, I have side A, that's one connection. I'm looking for side B, and I have angle B. So that's my other connection. I have 3 pieces of the information, so I can find the fourth. Times by sine of 17 on both sides. And we get B equals 18.005, so basically 18. Okay. Thing with law of sines to make sure is that you're matching things up the right way. Okay. Tops always have the sides, bottoms always have the sides. Okay. Now we're looking for an angle, but we're still using law of sines, and I know we're still using law of sines because we've got a side angle connection. I'm looking for angle B. I know it's side, so this time I write sine of angle B on top because that's what I'm looking for, and which I can do as long as I make the other side match in format. Okay, now I'm going to start out by times and by 14. Problem is, this won't give me my answer, not quite as easy as the other way of doing it, because I've got to separate that sign from B. So I do the inverse of this whole fraction, and it's really easier if you're able to just do it this way. You could separately divide those and multiply, then find the inverse, and if you have a calculator that works that way, that may be what you have to do. But if not, and if you're in class using one, it's easiest to do this, because then I just get the inverse sign, make the fraction, type in the regular sign of 73 degrees over 20, all of that times by 14, all of it in the parentheses, then I hit enter, and I get my angle, which is 42, and did they say to round? They didn't, so probably to the nearest tenth, 42.02 degrees, which would round up to just 42 degrees. Okay? So it's the same process. Again, looking for angle B, so sine of B over 26 equals sine of 70 over 31 times by 26, doing the inverse sign of the regular sign of 70 over 31 times 26, and that's going to equal angle B. So again, that's what I type into my calculator. And we get about 52.01, so basically 52 degrees. Now, the things to pay attention to on the outside when we're looking for the angle is the only time we use the inverse sign. Because this one we're not looking for its angle, we use the regular sign. And this 26 is inside because it's this whole piece that I'm finding the inverse sign of. Now, if we look at 13 and 14, okay, same exact process. Difference is isn't written. So I have angle A, I have side A. Finding angle C, side C, I have everything I need. So sine of angle C over 13 equals sine of angle A, which is 91 degrees over 32, times both sides by 13. Do the inverse sign of that whole fraction. That's going to give me angle C, which, when I type it in, gives me 23.96, which I just round up to 24 degrees. Okay, 14, same idea. Angle A, side A. Looking for angle C, side C. So we go sine of angle C over 9 equals sine of angle A over A, or sine of 102 over 34. Times both sides by 9. Take the inverse sign of that whole thing, and that gives me my answer, which was angle C. And we get 15.0061, so basically 15 degrees. Okay? So that's the two ways we basically deal with the sine. Now, let's look at 15. It says, solve the triangle. When we talk about solving a triangle, it means we find every single angle and every single side. Okay, well, we know angle B is 40 degrees, side B is 31, angle A is 10, and that's all we know. Now, using law of sines, I've got a connection here, I can make a connection there. So sine of angle A over A would equal sine of angle B over B. Times by 10, take the inverse sine of the whole thing, and that'll give me angle A. So this is very heavily reliant on using the calculator to find a lot of the information here. So, and we get 11.9671. It says round to the nearest tenth, so we'll just round to 12. Okay. So now, thinking of a triangle, if I have two of the sides, we can easily find the first side by subtracting them from 180, right? So if I go 180 minus 12, that gives me 168 minus 40, that'll give me 128. So I have 128 degrees for angle C. Now we can find side C. So I go C over sine of 128 degrees equals, and I would start out with the connection we had to begin with. So 31 over sine of 40 degrees. Okay. Then we times by the sine of 128. Now notice we know both angles, so I'm not going to have to use the inverse sine. This is kind of how we can see the difference here. So I just type in the calculator, 31 divided by the sine of 40 degrees, and then we multiply that by the sine of 128 degrees, and that gives us our answer of about 3.67. So if we round, 3.7. And there's my whole triangle. Okay, and there's the two different ways you end up using the law of sines: to find an angle or to find a side. But remember, you've got to have a starting connection, because if we look at 16, side, 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 no angle, there's nothing I can start with. Okay, this is where the law of cosines comes into play, because I've got three sides connecting to one angle. So I can use that to build a connection. Okay, so I would go, let's go for angle B. So the opposite of angle B is 22, and that's important to note because that's the one that's by itself. So I go 22 squared equals 20 squared plus 23 squared. The other two doesn't really matter the order. We times that by the cosine of angle B, which is what we're looking for. Because we're looking for this cosine of angle B, I've got to deal with all this front stuff and get it over to the other side. Okay, so I'd go 22 squared, okay, is 484. Oops. Okay, 20 squared is 400. 23 squared is 529. Minus 2 times 20 times 23, which is 920, cosine of B. Now, this is being multiplied, so I can't just add and then subtract. So I've got 400 plus 529, which is 929. I can't subtract the 920 from it. Instead, what I have to do is I have to get everything on the other side. So I subtract 929, so 484 minus 929 gives us negative 445 equals negative 920 cosine of B. Divide by negative 920, and I could simplify this, but I don't need to, because I'm looking for the angle. I'm just going to do the inverse of that fraction. And I can write it exactly the way I have it. I can realize that the two negatives would make it positive, or I can just go with that. Okay, so I do the inverse cosine of negative 445 over negative 920, making sure I'm in degree mode. If not, it'll all be messed up. I get 61.07, so basically 61.1 degrees. So again, we have measure of angle A, measure of angle B, measure of angle C. I now know B is 61.1. I have A, which was 23, B, which was 22, and C, which is 20. Okay, and now I'm done with the law of cosines. I could use it again, but I'm not going to. Now, there is a way that you could try to make this easier on the calculator. Okay, and the way to think about that is like this. Okay, so basically it would be, we know we're doing the inverse of cosine of, we started with this, subtracted this and this, and then divided by that. And I got the inverse cosine. And you type it in like that, and it'll work. Okay. However, now I need either angle A or angle C. Let's go for angle C. So I've got a connection now, so I go sine of angle C over 20 equals sine of 61.1 degrees over 22 times by 20. Then I take the inverse cosine of that whole fraction, and I'm going to get angle C. And that gives me 52.7 when I round. So angle C, 52.7. So I go 52.7 plus 61.1. Subtract that from 180. And I get my third angle, 121.3 degrees. And there's my full triangle. And that's how I can use the law of cosines with the law of sines. So, if you liked this law of cosines, putting it in the calculator, okay, the calculator version of this would look like inverse cosine of a squared minus b squared minus c squared over negative 2 times b times c, and that would equal angle A. So that's kind of a shortcut you can use. Alright, so we've got about 8 minutes, so I'm going to kind of try to go quick on these ones. Now, 17 and 18, 19, and 20, we like these ones because we're looking for the opposite angle here, which cosine works really great. So I have a squared equals 30 squared plus 28 squared minus 2 times 30 times 28 times the cosine, and we know the degree, it's 93 degrees. Now, I could solve this all out a piece at a time. However, the calculator can do all this, and I know I'm going to take a square root at the end to get a by itself. So I'm just going to type it in exactly how I see it, just like this. And that's going to give me my answer. So square root of 30 squared plus 28 squared minus 2 times 30 times 28 times the cosine of 93 degrees. Hit enter, and I get my answer of 42.09. So 42.1 if I'm rounding to the nearest tenth. 18. Set it up the exact same way. Okay, it'd be a squared equals 22 squared plus 21 squared minus 2 times 22 times 21 times cosine of 50 degrees. Now I'm going to take the square root of it, so I just typed it in my calculator. And I end up getting 18.195, so 18.2 if I round. Inches, I suppose. And this would have been miles. Okay, 19 and 20, same idea. Okay, so I'm looking for little c. I have angle C. That tells me I have c squared equals b, 11.3 squared, plus a, 29.2 squared, minus 2 times 11.3 times 29.2 times the cosine of 120.9 degrees. I know I'm going to take the square root of that, so I just type it in my calculator, and we get 36.32, so 36.3 meters. For 20, same exact idea. Okay, finding angle B, or side B, I have angle B, so I go B squared equals C squared plus A squared minus 2 times C times A times the cosine of 118 degrees. Now I'm going to take the square root of it, so I just take the square root of it and put it in my calculator, and I get 30.005, so we'll just say 30 centimeters. Okay, not too bad, right? Okay, let's look at 22 first. So now we've got all the sides, okay? And that's the part that's tougher, but we want angle B. So side B is the one by itself, so I go 20 squared equals 28 squared plus 15 squared minus 2 times 28 times 15 times the cosine of angle B. So then I solve that by 28 squared plus 15 squared. Okay, so that's 1009 minus 2 times 28 times 15. And if you liked that version over here, right, that, by all means, use that version of it to just type it into the calculator. That was 840 times cosine of B equals 20 squared is 400. So 400 minus the 1009 gives us negative 609 equals negative 840 cosine of B. Divide by negative 840. So I'm going to get the cosine, inverse cosine of 609 over 840, because the negatives cancel, equals angle B. Then I type that into my calculator, and we get 43.5 degrees. So angle B, 43.5 degrees. Okay. Now 23 is the same way. Okay. So, but it's angle A, so I go A is by itself. And that's a critical part of doing it, right? Times the cosine of A. So I get 121 equals 389, that's these two together, minus 340 cosine of A. So 121 minus 389 gives us negative 268 equals negative 340 cosine of A. Divide by negative 340. We end up with the inverse cosine, because we're going for angle A, over 268 over 340 will equal angle A. So angle A becomes 37.979, so basically 38 degrees. Okay. Now for the other two, we're going to have to use the law of cosines, then the law of sines. Okay. So first, I need to find side C, then we can find angle A. So I go C squared equals 24 squared plus 10 squared minus 22 times 24 times 10 times the cosine of 110. Now we can put it in our calculator, or we can do it a piece at a time. So if you wanted to see it worked out, I showed you it worked out. Okay, but I would suggest from right here, typing it in the calculator. Okay, now using that connection, we're going to use the law of sines. So sine of angle A over 10 equals the sine of 110 over 29 times by 10 on both sides. We get the inverse sine of that fraction, which gives us 18.9 degrees. And there's our answer. So 24, we're going to have to do a similar manner. So I'm going to try to do it pretty quick. Okay. So setting it up, we have side B, 22 squared equals 20 squared. Actually, we're looking for angle side A first. So A squared equals B squared plus C squared minus 2 times B times C times the cosine of 108. Take the square root of it, stick it in our calculator, and we get 33.999, so we'll say 34. Now we can build a connection. Okay, sine of angle B over 22 equals sine of 108 over 34 times by 22. Take the inverse sine, and we get about 37.98 or 38 degrees, so we'll do the last problems in another video.